Okay, we're going to take E. coli and dilute it 4 different times. We're going to take 1 milliliter of E. coli, add it to 9 milliliters of water or nutrient culture, and then we're going to keep doing this after we mix it together, and the resulting dilutions will be 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4. How that calculation is done is right here on the first page. Take the volume of the sample, which would be 1, divided by the volume of the sample, which is 1, plus the volume of the diluent, what it goes into, and that's 9. So that'd be 1 over 1 plus 9 is 1 over 10, which is equal to 10 to the minus 1. So let's do these dilutions, and then we're going to put samples on petri plates to grow. Okay, here are 4 petri plates, but before we do that, here's our E. coli. Here's our tube 1, 2, 3, 4. Notice that there's 9 milliliters in all of them. We're going to turn this pipette back to 1.00. Showed you how to do that in another lab. And, okay, put a new tip on, sterile tip. Okay. Sample from the E. coli. Press down on the green button. Reach down in here. Suck up 1 milliliter. Now add that 1 milliliter to tube number 1 and dispose of the tip. Now I'm going to take tube number 1 and shake it. Okay, so now that is a 10 to the minus 1 dilution. Now I'm going to take 1 milliliter from here, put it in the next tube, and this is called a serial dilution. Not like cornflakes, but like a series. So take 1 milliliter, and the resulting dilutions will be factors of 10. So if that was 10 to the minus 1, this is now 10 to the minus 2, which is 1 in 100. Okay, I'm going to repeat that. So 2 goes into 3, mix it up, 3 goes into 4, and I'll be right back. Okay, now that we have our dilutions 1, 2, 3, and 4, we're going to put them on these petri plates. So I'm going to call this 1, 2, 3, and 4. Just make sure we don't get the lids confused with each other. So now we're going to put 0.1 milliliters on the petri plate. So we use the pipette set at 100 microliters, which is 0.1 milliliters. We put a sterile tip on, take a sample from tube number 1, and open up the lid and squeeze it on there. Now, to streak it across the surface of the petri plate, we're going to use these L-shaped cell spreaders. And the way this works is you simply rotate that around, and you're getting an even thin coat all over the surface. And we'll repeat that with tubes 2 through 4. Okay, so here are the 4 petri plates, 1, 2, 3, 4. Remember which one is most concentrated? That was the first one. The least concentrated, most dilute, was number 4. Now, when we flip these over, we can get a better view of how many bacteria are growing. Plate number 1 is totally overgrown, so that's unusable. Plate number 2, I mean, there's thousands of colonies. We can't count them. Plate number 3, we might be able to count them, but plate number 4 is the most dilute, and look, we can probably get a count. Let me zoom in. Okay, this is going to take a few minutes, but I'm going to put a black dot everywhere there's a colony. 1, 2, 3, 4, 5. Okay, I counted 182 colonies. So how do we use that information to back calculate the original concentration of bacteria? Okay, we had 182 colonies. And what we're trying to do is determine the colony forming units, CFU, per milliliter of the original bacterial sample. Okay, so we take the number of colonies, 182, times 1 over the dilution. Now, the dilution of petri plate number 4 was 10 to the minus 4. So that is 1 over 10 to the minus 4. All right, and then we multiply it by 10. Now, the reason we multiply it by 10 is because we sampled 0.1 milliliters of the original sample. We want to know how many for 1 milliliter, so we have to multiply 0.1 times 10 to get 1. Okay, now this can be a difficult calculation for some people. What I like to do is convert the exponent into a decimal. So that is 0.0001. Okay, I've got in the handout how to convert negative exponents into decimals. So now that we have this, we can say 182 times 1 over 0.0001 times 10. But look, you can also convert this into a single digit. Basically, look it up in the PDF handout. This would be equal to 10,000. Okay, so we have 182 times 10,000 times 10. Look, I don't even need a calculator. That's 182, and then 4 zeros, and then 1 more 0. So that is 18,200,000 bacteria per milliliter in that original culture tube. So you want to make sure you know how to do this calculation, and also let me show you the dilution calculation. Okay, for your dilution calculation, let's pretend you add 1 milliliter into 999 milliliters. So the dilution formula is dilution equals the volume of the sample divided by the volume of the sample plus the volume that it's diluted in. Okay, so again, we took 1 milliliter, added it to 999. So that's going to equal 1 over 1 plus 999. That's 1 over 1,000. Okay, but you should be able to work with decimals and exponents as well. So 1 over 1,000, if you just put it in your calculator, you get 0.001. You can also express it as an exponent, and that's 10 to the minus 3. You would move the decimal place 3. Okay, so we've got all this in the handout. Be prepared to do the dilution calculation. Be prepared to determine the colony forming units per milliliter.